Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 4, Determinants and Cramer's Rule. So before we can talk about determinants, we need to look at a few terms. You need to know what a major diagonal of a matrix is and what a minor diagonal of a matrix. The major goes from the top left to the bottom right. So this is the major from A to D. The minor diagonal goes the other way. So from C to B is the minor diagonal. Now, I don't have a fabulous definition for determinant because I looked it up many different places. And as we go through and work with it, I'll try to describe a little better what it is. But one thing a determinant tells us is whether or not the matrix we're talking about has an inverse. Now, we're not going to do a lot with inverses until section 5, but this is a fact that you need to know. So make sure you have this in your notes, that when we calculate the determinant, if it turns out to be 0, the matrix has no inverse. And then if you tried to enter it in your calc would think you're being silly and tell you to forget it. So now we need to learn how to find a determinant. And first, just notice only square matrices have determinants. So we're going to start with a 2 by 2 because that's the simplest square matrix. To find the determinant, you take the product of the major diagonal and subtract from that the product of the minor diagonal. So to find the determinant of matrix A, which is a 2 by 2, these symbols right here sort of look like absolute value, this bar and this bar. But when you know that the letter A is the name of a matrix, when you have these bars on both sides, that is indicating to you to find the determinant. So I thought I would put this in letters first. So these two bars on the side here are telling you find the determinant of this 2 by 2. So to do that, we take the product of the major. This is the major diagonal, A times D. So we do that multiplying. And then we subtract C times B, the product of the minor. So let's look at that with a number example. So here, if we're to find the determinant of this matrix, we take 7 times 6, and we're going to subtract from that -1 times 9, which is -9. And 42 plus 9 is 51. So the determinant of this matrix is 51. Now we're going to do some examples. I'll show you where we use determinants. So maybe a developing definition is that a determinant is a number that we find in a matrix and then we use it to accomplish things and to find things. Next, we're going to look at finding the determinant of a 3 by 3 matrix. And again, it's the product of the major diagonal minus the product of the minor. Except when you look at a 3 by 3, you actually have 3 major diagonals. This is, I'll just draw lines through them. This is one major diagonal, and then 1, 4, and 7 make up another major diagonal, and 2, 5, and 3 make up the other. Now, you can try to do this by jumping around inside the matrix, but I find that very difficult. I get lost in that. So I saw a method one time that I really like. To line up these diagonals, it's a good idea to take this column and just rewrite it right next to the matrix. And then likewise with this middle column, put it right next to the matrix. And now I'm going to underline the three major diagonals. Here's one right here, the 2, 3, 6, the 1, 4, 7, and the 3, 5, 2. So let's do, and I'll write it out. Let's do, we have to multiply all those and we add all those products together. So I'm going to write this out the long way so you can see it. So all this work is for the major. We have 2 times 3 times 6 plus 1 times 4 times 7 plus 3 times 5 times 2. Now we'll do all that math, and then we need to subtract from that the product of the minor. So let's put in blue here the three minor diagonals. Here's 1, 7, 3, 3, the 2, 4, 2, and the 6, 5, 1. So I'll write out those products so you can see them. Okay, take a minute and study these and make sure you see where I got all the numbers from. So now doing this math, if you multiply this out and add up the three products, I get 94 for the major diagonal. And please don't lose track of this subtract sign. And then when we multiply these products and add them all together, I end up with 109. So that means we have to take 94 and subtract 109. And if I did my math correctly, I got negative 15 as the determinant. Now, after we do section 5, we're going to learn to find determinants on our calculator. But I put a few of these on your assignment for this section because you need to understand what your calc is doing for you. So this isn't going to be on the test that you have to find the determinant of a 3 by 3 with pencil and paper, but I want you to do it a few times so that, like I said, you know what the calc is doing for you. The next thing we're going to look at is Cramer's rule. This is a way of using determinants to solve a systems of equation. So what we learned back in section 1 or 2, we learned how to take a system of equation like 3x plus 4y equals 7 and negative 2x plus 10y equals 3, and we put the coefficients into a matrix, and then we had an xy matrix, and then that equaled an answer matrix. So when you see this, I hope you can see where that comes from, a system of equations. A is the coefficient matrix and C is the answer matrix. Then we need to find some determinants. So Cramer's rule is full of determinants. This denominator, which we will be dividing by, is the determinant of the coefficient matrix. So that one we'll have from our equation. But this A sub x matrix, we have to build it. And this A sub y matrix, we have to build that one too. So these two we have to create, and then we will find the determinant of each of those, and once you have those three numbers, you do some dividing to find your answers. XY is the solution. It's the answer to the system of equations. Now, this sentence will be a little confusing when you read it here the first time, but after we do the example and then you go back and read it again, it'll make more sense. It's telling us how we build these two matrices. This is like when we put the two equations together in a system of equations. Remember, we did it by substitution or elimination, and I called it mushing them together. Well, creating these two matrices is the mushing together part. And so what we do inside the coefficient matrix, we take out like in A sub x, we'll take out the x coefficients and we'll put in the answers. And then we want to find the A sub y matrix, we'll take out the y coefficients and put in the answers. So do write this down, write down Cramer's rule, and then have it sitting side by side here when we look at our example. So the directions say, solve this system using determinants. And when you use determinants, you're using Cramer's rule. So the first thing we're going to do is take this and write it as a matrix equation. So pull out the coefficients to make the coefficient matrix. And then we have the variable matrix, which has the x and y in it, and then equals the answer matrix. So now we need three things to use Cramer's rule. We need the determinant of matrix A. This one right here is matrix A. So that's easy enough to find. Then we need to find the determinant of a matrix we haven't created yet, A sub x. And then we need to find the determinant of another matrix we need to create, A sub y. So I guess we could do this determinant first. So the determinant of A, major subtract minor, so it's 5 times 4 is 20, minus 1 times negative 3 is negative 3, so it becomes minus a negative, which is positive. So the determinant of A is 23. Okay, now that's not x or y yet, but we will use that to find x and y. Next, let's create matrix A sub x. And the way we create that matrix, see these two x coefficients? You remove them from A and you replace them with the answers. So we take 5, 1 out and we put in 9, 11. And then keep your y coefficients. All right, so there we've created A sub x. Now let's create A sub y by removing or pulling out the y coordinates and replacing them with the answers. So we're going to leave the 5, 1 in there and replace the y coefficients with 9, 11. Now we need to find the determinants of these two matrices. So first, the determinant of A sub x. 4 times 9 is 36, minus 11 times negative 3 is negative 33. So again, this double negative becomes positive. And 36 plus 33 is 69. So the determinant of A sub x is 69. Again, that's not our answer, but we're getting there. The determinant of A sub y, 5 times 11 is 55, minus 9 is 46. So now I have the three determinants that I need. And take a look at Cramer's rule and you can see how it says we use these numbers to divide to find our x and y. Cramer's rule says to find x, we use the determinant of A, and we are going to divide that into the determinant of A sub x. So we have 69 divided by 23, which, oh, this turns out nice. That's 3. So that's my x answer. And now to find y, Cramer's rule says you take the determinant of A sub y, which is 46, and you divide by the determinant of A, which is 23. And again, that divides evenly, 2. So our final answers are 3, 2. So feel free to back that up and watch it a few times. There is Cramer's rule with 2x2s on the test, and you do need to know this for next year's math. And so spend a little time on Cramer's rule. It's once you get the hang of it, it's not hard, but there's just a lot of steps. All right, one more use of determinants. We're going to use them to find the area of a triangle by making a matrix with its vertices. So we did this kind of back in section 1, I think, where we just made a 2x3 with their vertices. We have x, y, and then this last row is a 1. And then we have another x, y, the last row is a 1, and then x, y is a 1. Now, you may ask, what's the deal here with this plus minus? Well, when you find the determinant of a matrix, we already had an example in our notes where the determinant was a negative number. But we know that area is a measurement, so it absolutely must be positive. So this plus minus is here for you to use. If you do the determinant of the matrix and it turns out to be negative, you will multiply it by a negative 1/2 so that the area is positive. If the determinant turns out to be a positive number, you just multiply it by 1/2 and your area is still positive. So this plus minus here is here for you to use if you need it to make sure your area is positive. All right, this is the last example for this section. You're almost there. We are told to find the area of the triangle using matrices. This could have also said find the area of the triangle using determinants. Same thing. So we're going to set up a matrix. This stands for area this time. The area of this triangle is plus or minus 1/2 times the determinant of the 3x3 matrix that we're going to make with these vertices. So I'll just use this vertex first. I'll put in the x of -3, the y is 1, and remember this bottom row is just made of 1s. Then we can put in the 1, 3, xy, and again with the 1 on the bottom row, and then the 2, 1 vertex with the 1 on the bottom. So just reviewing, to find the determinant now of this 3x3, we write that first column again and the second column, and that helps us see the major diagonals. I've underlined the major diagonals in blue, so I'm going to leave my plus minus 1/2 here to do later. So -3 times +3 times 1 is 9. 1 times 1 times 1 is 1. 2 times 1 times 1 is 2. So there we have the product, all the major diagonal products added together. Remember, in determinants we subtract the minors now. So let's mark the minors in blue. So the first minor diagonal, 1 times 3 times 2 is 6. 1 times 1 times -3 is -3. 1 times 1 times 1 is 1. So you'll notice I put the determinant in brackets because the PEMDAS, if you will, of this is that we need to do the determinant first, and then we'll get our answer, and then we'll do the multiplying by 1/2. All right, looks like I missed a negative sign here that I'm going to put back in, that -3 times +3 is -9. Sorry about that. So now if we add these, we do get a -6. And then keeping my subtract sign, I'm coming over here, subtract, we get a 3 plus 1 is 4. So -6 and -4 gives me -10. So now I need to use the -1/2. So this gives me -1/2 times the determinant of -10, so that I can get a positive area of 5 units squared. All right, you have all the knowledge you need for section 4.4. Have fun with math.